So we are in Knuth Morris algorithm. This algorithm basically, while comparing a substring in a string, saves time and gives efficiency. So look, we have a string over there, ONIONIONSPI, and we have to search for the index from where the substring ONIONS is found. Okay, the brute force method can be like traversing all the characters in a string starting from zeroth uh, index, and while comparing, if we find the first character of substring matches with the character of a string, we stop there and then check for each character of substring to be matched from upcoming characters in the uh, string. If found, then we return the index of this character. Otherwise, again we come back to the next character in outer loop and compare the substring. It goes like same. So this is the brute force method, and in worst case the complexity can be that whole length of the string is compared, and each time the first character is matched, but upcoming character forthcoming characters are not matched, so it becomes the complexity of n into m, where n is the length of a string and m is the length of substring. Knuth-Morris algorithm saves time in this manner. Suppose in this case, what we can see that while comparing, suppose if we found that zeroth, first, second, third, fourth, and fifth character we have. So in this case, for zeroth, first, second, third, and fourth character are matching like this: 0, 1, 2, 3, 4 character are matching. But while comparing the fifth indexed character in substring, uh, it doesn't matches with the character in a string. Okay, so what we look into, that rather going again to this character, that is the next character in outer loop, or can we find a process or method through which we can only go to the next character without backtracking the outer loop? We can move forward without backtracking the loop. So it becomes the complexity of of n only, because we are traversing each character only once without backtracking or going back to it. So the idea is basically, if the like in this case, the first and second character is found again in this string. So if at this position we have break the similar characters matching, so what we see, because these two characters also there are same, so we don't know about everything, but one thing we know, that because we have come up to there and first two character matches, so these two characters are going to be same, that is up to these two index we have already compared, and we should start from this position to compare in the string. And there is no case where it is futile to compare rest of the characters. We just know that these two character matches, so we start from this part of sub string without playing with the or backtracking the original string. So like how can we make a record of where we have to start again? Like in this case, suppose this character is, this is the first appearance of it, this is also the first appearance of it, uh, means sequentially in corresponding manner and not alternatively. This is also the first, but this o is present in zeroth index. So we say that we have found one um, appearance of it already one, like again n is the character in substring. So we say that up to this, like we have found two characters now sequentially is very important. We have found two characters sequentially same. So if someone stops, doesn't find the match here, so he comes to this number that is mentioned over there, and from this indexed the, like from here he will match the string, he or she will match the string, because these two characters first second will be same. Uh, because while we backtrack to this string, the idea is basically that there is possibility that we can find the substring from the next respective uh, uh, character in outer loop. So this method of Knuth Morris covers this idea also, and we don't need to backtrack. This is Knuth Morris algorithm.